I have never printed this quickly before. And even at those really quick printing speeds with some aggressive, very aggressive jerk and acceleration settings, I'm getting just about the highest quality prints that I've ever gotten. Look, there's no ghosting right there. That's where all the ghosting would appear, and you don't see any of it, even though that outer wall was printed at an actual 200 millimeters per second speed. I'm calling this printer the Kossel Evolution. And you know, it's funny because I got this kit given to me just about 2 years ago from GearBest. And it was the first kit that GearBest ever sent to me, and I was stoked to get it because Delta 3D printers are really exciting. But you know what? You can no longer buy this printer, period. They're out of stock on all of the websites. Anycubic is no longer making them, and it's understandable why. When you can get printers like the FL-Sun Q5 that I talked about in the last two videos for less money than a Kossel costs, why would you buy a Kossel? There's considerations. It's got kind of a smaller build platform, and there's other sort of drawbacks. So really, it was time to retire this frame design, but I still think it's pretty cool because there's something industrial appealing about it, especially now that I've got these metal corner brackets installed. But of course, the original corner brackets were a 3D printed design by a guy named Johann, who lived in Seattle at the time. Now Johann, tremendously influential in the rep movement. He designed the Rockstock and then the Kossel both. So just really cool projects that he came up with. And then of course, China being China, they picked up on his projects and they made a very cheap kit for $200. That's what the Anycubic Kossel cost at the time, which was, yeah, right there with the cheapest printers you could get. I mean, think about the Ender 3. That one cost, what, $240 when it first came out. So for the price, considering that it was a Delta and it just looked so cool as it moved, it was definitely right there with it at the time. But it suffered from one major problem. The control board, which was an 8-bit processor, an AT2560 running Marlin. Now, Marlin never been as strong as the RepRap firmware, so it just didn't do deltas quite as good as RepRap firmware, and the 8-bit chip couldn't do the math fast enough, so you couldn't actually use this Delta printer for what Delta printers are best at, and that is printing very quickly. So because the quality and the performance wasn't there, even though this printer was the same price as the other frame designs, it just didn't work, and so it didn't catch hold, and now it's dead. And so building up a Kossel today would be similar to getting a classic car and sort of fixing it up in your garage and maybe, I don't know, resto modding it, I guess you would call it, just to say that you can. Just to have pride and ownership and to be able to, understand every single little nut and bolt on your car, on your printer. So that's basically what I've done, just in time for nobody else to follow this project. But let me show it to you anyway, because there's some interesting things to talk about, and we can get into the mind of Johann and see what he was thinking. Starting at the top, it's not hard to understand what was on Johann's mind. Basically, he just wanted to arrange these three aluminum extrusions, 2020 extrusions, into a triangle using these corner brackets, which were originally 3D printed. Of course, I've upgraded mine to these metal versions, which you can get from China for like $60, and really they're not worth it. The plastic ones were every bit as accurate in hindsight, but I was having problems and I didn't know if my frame was straight, and I thought the metal corners might fix my problem, but that wasn't the problem. So don't buy those, they're not worth the $60. Anyway, down here at the bottom, we can see same idea, just double thickness, or actually triple thickness, with 2 rows of the extrusion to give you enough room inside there to hold the electronics. Now, as I originally got this kit, it had different electronics. And in fact, let's go over the way that I've got this built right now. Turning this printer on its side reveals what I got up to underneath the printer. There's this cork underlayment underneath the heated, the PCB bed heater there, and that keeps the heat from radiating down onto the control board, which is held in place by these ABS prints mounted right here into the backside of the aluminum extrusion. Also keeping the board cool is this 60mm fan, which blows air over the board. That's held there with another ABS print, and the 60mm fan is more quiet than a 40mm fan would be, so that's why I used it. I like to keep the noise down on my machines, and to that end, I also used these TPU soft rubberized feet that I printed as well here. That keeps the sound, which tends to get transferred through the aluminum frame, through the metal frame, into the table. And then the table acts as a resonant device, kind of like the body on a guitar. So putting these feet really dampens that noise and keeps it quiet. There's the obligatory cover print here, which just keeps the exposed mains, joints there, just covers them up so you can't accidentally shock yourself. And then, of course, I've got a fanless 12-volt power supply unit with a plug and a switch for turning the printer on and off. Here we see the hot end, which is pretty much stock from the Anycubic design up here. So this metal cage and the way that the E3D version 5, I think it's a version 5 in there, is held in place. That's all stock. But I changed the end effector. That's the green piece here. I have split cooling that cools the nozzle from both sides. I've put an E3D, Volcano extruder, that's the Volcano hot end on there. And I've got a BLtouch bed leveling sensor there. On top of that, I've got these magnetic ball and sockets, ball and socket joints. And those are mounted to these high-wind rails, or these are knockoff high-wind rails. And I actually added those myself, but Anycubic sold a version of this printer called the Linear Plus for like $250 that came with those. However, my low quality, I paid $75 for all three of those rails, and they're low quality. I try to get that to come through on, hopefully you guys can see that. There's wiggle. There's movement in that, and it's really not supposed to have any movement. However, it's less movement than the stock. So this was Johann's original idea for movement, or constrained movement up and down the printer. And you can see that he had, this is the precursor to the V-grooves that we all have now. Before China started manufacturing all those V-groove extrusions, we just had the round pulley wheels going in this, there's like a step inside of there. So it's not ideal. The V-grooves are definitely an advancement, but that single row of bearings there, it's just a single bearing, means that the bearing wheels can wiggle quite a bit. So you would need two bearings to eliminate that sort of a slop. And yeah, this didn't have it. So even the stock solution had play. So this has less play than the stock solution. Still not ideal. I wish I had higher quality rails. But even with that movement, I'm still getting phenomenal print quality and accuracy out of this printer. You can see down here, the bed is the original glass plate on top of this PCB bed heater, which I added onto the printer. And there is the power supply that I also added. The original power supply that came with this printer that had no heated bed was just a brick. It's just a power brick, and all that needed to do was heat up the nozzle, which isn't, not that much of a power draw to just heat the nozzle. The bed is what draws all the power and necessitates the larger power supply. Over here we see the extruder, which is a pretty simple, we've seen all these ones before, so nothing fancy there. And then the filament spool holder was just this crappy design, laser cut acrylic. I broke the cross pieces and had to print up new ones out of PETG. The control board that I'm running is a Duet 2 Wi-Fi, which is a $175 component, which definitely increases the cost of this printer, almost doubles it. But you know what? We just don't give enough credit to good electronics. That's more than half of the functionality. We could have made, printers, the frame and all this, back in the 60s, the 1960s. And yet it's not until today that we're able to make low cost 3D printers, primarily because our, Moore's law on electronics have gotten so good. So that is just really responsible for the good printing. And without that board, this would not be a functional printer, period. And that is the current state of the Kossel. And functional as it is, there's one more change that I want to make to it. I want to replace the glass print bed with an aluminum bed instead. So the current glass bed came with the printer, and it's nice and flat. This genuine BLtouch sheet works really well. In my experience, the genuine stuff is superior to the Chinese stuff, but that's beside the point because I don't have enough BLtouch to coat the new aluminum bed with BLtouch, so I'll have to get to that at a later date. Anyway, the ears here, or I don't know what to call these little dogs that hold down the PCB bed heater. They also function to sort of pinch from the sides to pinch the glass. So there you go. It doesn't move. It is securely in place, but I can just pop it up. You saw me just pop it off. So I would like to basically have a bed that's permanently attached and that looks more aesthetically pleasing. I don't like this red ring, stupid as that and shallow as that seems. I want it to be all black and green and just look really sexy. So we're going to cover all that with a piece of aluminum that is this shape. And I just cut this out of some cardboard, thin board stock here. I used the top of the printer as a template. And so that is what we need to cut out of this sheet of aluminum, which I bought like 2 years ago from McMaster-Carr. I was going to use it on a different printer for the heated bed, but I changed up my technique there. But yeah, there's enough of it left after 2 years worth of projects where I've been stealing corners away from this. There's still enough to cut the bed for the Kossel. So let's go into the garage on the table saw of all things, and we'll get this shape cut out. So this is not meant to be an safety video or even an instructional video. I'm just showing you how I felt comfortable using my table saw to achieve the results, to good results, I should say. So basically I cut this 3/4 inch piece of plywood down to make it into a sled of sorts. And then I screwed the aluminum using the offcuts, just drilled holes into the offcuts and mounted with 2 screws, mounted the aluminum to the sled. And then after that was firmly sort of securely mounted, I just, ran it through the table saw, just like you see me doing here. Now, the thing is, this does spit a lot of aluminum shards into the air, so I went and grabbed a hat to keep the aluminum out of my hair. And yeah, there was cut number 1, just 5 more cuts to go. I won't show you all of them, won't make you sit through that whole process, but you can see me setting it up for cut number 2, and I just eyeballed the scored line down along the edge of the sled, and that's how I was able to gauge where I was cutting. This looks science fiction to me. Maybe a science fiction movie from the 90s, but still science fiction. So there's a lot more work to do on the bed still. I need to cut out slots for these belts so the belts don't collide. And the reason that I made the bed sort of oversized in the direction of the belts is that I want to reuse these screw points that I drilled and tapped these holes into the corner brackets, and I want to reuse those attachment points. If I used attachment points out here, it just kind of would get in the way. So I like those, tucked away into the corner. Yeah, so let's get that done. The final thing, the difficult thing to do here will be to recess some pockets into the aluminum here with a router or a Dremel tool so that I don't have collisions with my solder points here on the bed. And I can't, I could just turn the bed upside down and have the filament, or the elements, the heater element, face downward toward the cork. But then the heat would have to rise through the fiberglass garolite before it ever got to the aluminum. So that's less efficient. It turns out that those holes were through holes, which is awesome. I was able to pull the wires in from the backside, solder them in place, and then use the aptly named flush cutters to cut the solder off completely flush with the board, or very nearly so. The remaining protrusion will flex out of the way because this fiberglass substrate, the garolite, is plenty flexible. Now the only thing I need to do is get some of this Kapton tape here and just put a little piece of it over the solder, although I tested it without the Kapton tape and it worked just fine. So even if the Kapton tape fails on me and the solder ends up touching the bed, apparently it won't cause too much of an issue. Okay, so the bed is installed and it's looking good. And now what I want to do is run another one of these test frames to test the part accuracy out at the limits of the bed, out the outer edges where the prints get inaccurate. So to that end, I've got this 45-degree rotated frame. I want to see what it does in 45. You know, I'm just challenging the frame. It seems to be printing perfectly at 90 degrees, you know, the normal orientation. So let's see what it does at 45 degrees. Now, as it gets there, watch this ball here. See how that ball popped out of joint? That's really bad. We'll watch it happen again. And I tried to sort of hold that, like pinch the ball into place to keep it from popping out with my hand. And what happened is all the other balls popped out of their sockets. So basically, this is a moment where the forces going through the hot end, or through the nozzle because it's getting too close to the print, are really trying to push the hot end around, and something has to give. And because these are, you know, the ball and socket joints can pop out of joint, that's what's happening. So I don't know how I feel about ball and socket joints. If I had rigid, you know, captive joints there, I might not be having any of these issues. I might get a squished first layer and then none of this. So there's like a give and take. Everything's got a trade-off, right? So that appears to be the trade-off for the zero lash movement of ball and socket joints. Of course, I'm only having this issue right here near the edge of my printable area. I'm printing this part without any infill, so the top layers are not going down quite as nicely as they could. I also forgot to make the layers go 45 and 45. They're all going in the same direction, so that doesn't help. Even after all that, I'm still getting great part accuracy. 130.4, 130.09, 130.45, and 130.37. So yeah, that's pretty accurate. I just kind of need to avoid this portion of the bed when making my prints if I can help it. Well, that behavior of the printer where it's popping out of the joints, it really bugged me. So I spent many hours, and I'm not exaggerating, many hours configuring the firmware here, just going through and playing with the variables, printing up test frames. And when it's all said and done, this is my new height map on the bed. Look at how flat that is. It's looking really good. So I think it's time to do a speed test on this printer. This is so cool. I'm doing a series of these test prints and then changing the settings on the machine just to dial it in to get it working perfectly as quickly as possible. And just watch how fast this thing moves. That's a rapid movement, so a point-to-point movement, and then it starts printing. And the first layer here is at 50% speed. So this is printing real time. The outer wall is 200 millimeters per second. I've never even printed that fast before, and it's getting zero ghosting at 200 millimeters per second. At 300 millimeters per second, it does have some ghosting. But the inner wall and the infill are happening at 400 millimeters per second. So very, very fast, which leads this print. Normally, I'd make this almost this exact same print as a test for every one of my printers, and normally it takes about 35 to 45 minutes to do this print. And in this case, it's going to take about 11 minutes. Just phenomenally fast. Here we see it doing some infill for the top layers, the top solid layers. See, there's a pillar on this side of the print and a pillar on that side, and so it's got to do this retraction test back and forth across the pillars. It moves between the pillars almost as fast as I blink. It's just so quick. I love it. And so yeah, that's how you use the E3D Volcano heater block, is you move really quickly and then you get no stringing. Before, when I was doing it, using the Volcano block on a slower printer, I was getting just really terrible stringing and oozing, the little boogers that appear on the walls of your print. But when you're printing quickly, like it's designed to be used, then it performs wonderfully. Watch it bridge. It just does such a great job of this, even at these super high speeds. There's very little drooping because it moves so quickly. The radiant heat coming off the heater block doesn't have a chance to stretch out those bridged filaments. Yeah, it's starting to do the spire. This is a part cooling test, and the spire can normally look pretty ugly. Like here's an idea of what happens. The spire gets to be, well, this is one that turned out really bad, like that. And yeah, so this is my little quick hack. I just did a Z-lift of 10 millimeters, so a centimeter each. And this really does help get a really clean spire. Now this is a cheat. I don't do this for my other prints when I'm testing part cooling. So this is just the way that I'm able to adjust all of my settings in my slicer to get this print to be perfect and print as quickly as I can. It'll start to mess up here in a second, but it looks like it's doing pretty good so far. Looks like I'm getting a little bit of stringing, which is funny. There we go. It's starting to mess up now. Not really though. God, it still looks pretty good. There we go. That is an 11-minute print. Taking a look at this test print, we see just a gorgeous thing. Those wispy hairs are easy enough to clean up. You can literally just hit them with a lighter if you want to do it the fast way. The lettering is nice and sharp. The bridging across the top is really minimal drooping. So as good of a test print as I've seen pretty much, except for all the hairs. Now, looking at the backside here, we start to see, let's see if I can get the light to reflect off that just right. Yeah, there we go. We can just start to see that sort of checkerboard hash pattern or whatever that just appears from Delta printers just because of the way that they work. But we see no ghosting. There is one slight sort of dimple along that edge, and that could be sort of a pressure advance issue, but it's actually most likely the last vestige of some ghosting. Here we see a print that was a pretty bad print. I was really pushing this thing to the limits just to see what I could accomplish. And we see the ghosting, the rippling. The period on the rippling is really spread out. Normally ripples are a lot tighter, which is interesting. But so once you get a hold of the period between those ripples, you can start to see how that might maybe qualify as a single ripple from some ghosting, ringing, echoing, whatever you want to call it. So yeah, except for this the hairs, let's just take those off here. There you go. That's as good as any test print that I've ever made, and I made it at 1/3 the print time. The final thing I need to do to it is just to cut this protruding moment where the PCB, there's nothing, it's just garolite. There's no heater elements out here at the extents of the bed. So I just want to cut that flush, and there's a number of ways that I can do it, but I'm going to do it the safe way here and just the slow, safe way. I'm just going to use the edge of the bed as a guide, and I'm going to score it until it comes off. And then I'll just cut the cork underneath it in the same way. I ended up using this wood file instead. And that right there is a pile of silicosis just waiting to happen. Good thing I wore a mask while cutting. So with these really promising speed test results and this flat bed, you know, in software, the flat height map, I want to revisit the 45-degree rotated frame and see how I'm doing as far as part accuracy out at the edges of the bed. And it's actually printing okay here. 130.16, 130.65, 129.2, and then 129.17. So we're not doing as good as we were doing before. So look at how fast this thing moves. It's crazy. In this direction, it's a different story. 130.01, 129.78, 129.97, 130.06. So good in this orientation. In the end, I've got a really good-looking printer here, designed by one of the godfathers of the RepRap movement. It prints incredibly quickly and makes really high-quality parts. So long as I avoid this sort of edge of the bed right there, I can get engineered parts for my functional prints out of it as well. So I will find use for this printer for years to come. Now, it's no shame that you can't get your hands on one of these. There are better options out there like the FLSun Q5 that I reviewed in the last video, and lots of comments want to ask about the Anycubic Predator, which looks like a great printer as well for only like 350 bucks. So there are better options out there, but this one is pretty cool for what it is. If you have a Kossel yourself that maybe has never worked like this one is was plagued with issues from the get-go. It didn't come with the BLtouch sensor. I mounted that onto it and tried to get it working with Marlin, and it was like a millimeter off. It was like I couldn't even get prints to stick to the bed using the BLtouch with Marlin. So I'm just really happy that I got as good of a result as I've gotten out of this machine. There's still some gremlin in there that the Duet board is trying to correct for it, and I can't chase that gremlin down, and it's not worth any more time to try to make it perfect. But if you want to give it a go with these with all these parts here and make your Kossel be as functional as it can be, go ahead and become a $5 Patreon supporter. I give any and all files from any of these videos to my $5 supporters. But, it only costs $1 to help this channel out. It's like something you'll never even know is missing. So I would really appreciate it, you guys, if you want to help me keep making videos, if you supported me over there. And here is a link to a video that YouTube thinks you're going to want to watch. Here's the link to that Patreon page. So thanks for watching. See you next time. Have a great day.